Okay, welcome to your first flipped lesson, and this is all about linear equations. It's about graphing lines and writing the equations of lines. This should be a review for most of you, but I think I'm going to show some of you something new, and we'll explain why it works tomorrow in class. But tonight, I really want you to watch and see how this works. So I guess the first question when dealing with linear functions is, why do we graph lines? And when I ask that question every year, I get great answers. Kids tell me it's a great way to look at data. It's a great way to look for patterns. And those are really good answers. But last year in Algebra 1, you didn't always graph in the context of a real-world solution. You would graph lines, and I guess I'm just wondering, why did you do that? What was the reason you graphed a line, and what was it really telling you? So in order to understand that, let's look at a typical equation. So let's say we have this equation here. You're solving x plus 3 equals 7. And although some of you are probably getting out your calculator right now, the rest of you have already solved this. You subtracted 3 from both sides and got x equals 4. What does that mean? Well, what that means is 4 is the only value for x that when you substitute it back in the original equation right here, you get a true statement. 4 plus 3 is 7. Well, if I ask you to solve this equation, basically I want you to do the same thing you did before. Give me the values of x and y that make this true. What number plus what other number gives you 5? And some of you might jump out right away and say, I have it. It's 1 and 4. 1 plus 4 is 5. And that's true. But other kids might have said 2 and 3. And that works. Some kids, instead of saying 1 and 4, may have said, well, x is 4 and y is 1. And that certainly is different. And it still works. And we could go through a bunch of answers. 2 and 3, 5 and 0, 0 and 5. Some of my clever kids might get crazy and do some negatives. And some of my troubled children might even throw in fractions. But I think you see very quickly that there are an infinite number of solutions here. And your job, like it was up here, is to tell me all the solutions. Well, we can't list them all. But what we can do is we can draw a picture. And if I plotted where x is 1 and y is 4, well, that would be this point. And when x is 3 and y is 2, that would be here. And 4 and 1 and 2 and 3 and 5 and 0 and 0 and 5, even 7, negative 2. Even negative 3 and 8, I think that's right here. Hey, even 1 and 3/8, 3 and 5/8 would work. And all of these points, when you connect them, give you a straight line. And what's that straight line represent? Well, that straight line represents every single value of x and y. We didn't list negative 2 and 7, but since it's on this line, it means when x is negative 2 and y is 7, we satisfy that equation. That is why we graph lines. You know, there's a saying that a picture's worth 1,000 words. But in math class, our graph is worth an infinite amount of words. This graph represents every single possible solution to x plus y equals 5. When x is 6 and y is negative 1, this equation works. That is why we graph things. Graphs represent the infinite solutions to an equation or an inequality. So, moving on. Let's talk about writing equations of lines. There are lots of forms of a linear equation. There are plenty of forms, but I want to highlight 3 of the main forms. The first being standard form. Standard form looks like this. A times x plus some number b times y equals c. It is standardized. It always has an x first followed by a y, being on the left side, a number c on the right, and the numbers, the coefficients a and b and the constant c, cannot be fractions. Standard form is not very useful, but it's standardized and it looks pretty. Now, having said that, there is a way you can go from standard form into this thing called intercepts form, where by manipulating this you can find the x and the y intercept very quickly. We'll talk more about that tomorrow since I'm limited in my time here, but I think you'll find that that's kind of a clever form. But the form everybody seems to love year in, year out, and all the kids, oh, this is the great, is slope-intercept form, and it is a great form. Slope-intercept form is great for graphing. If you have to graph a line, slope-intercept form, boy, that's the workhorse. That gets the job done. And you remember slope-intercept form, y equals mx plus b, m being the slope, b being the y-intercept. Really easy to graph lines that way. And I find that a lot of kids come to me and want to write their linear equations in slope-intercept form, which is fine. Kids can do that, and that's great. I don't think they're being efficient, and I think they're wasting a lot of time. My favorite way to write the equation of a line is point-slope form. Point-slope form generically looks like this. Y minus one of your y values equals the slope times the quantity of x minus the corresponding x value. Point-slope form is so easy. I don't know why kids don't use it more than they do. Let's take a look at that problem in action. So I love point-slope form, and I find one of my struggles is to convince kids just to try it. And I find that when they try it, they ask me why they were never taught this. And the sad news is when I break it to them that they've known it all along. And we'll talk about that tomorrow, but let's just take a look at how this works. Suppose I asked you to write the equation of a line passing through these 2 points, and you've done this a million times. But let's take a look at how this works. So the first thing I'm sure you want to do, regardless of what form you're using, is find the slope. So remember our slope formula from Algebra 1. Slope, abbreviated by the letter m, is your change in y over your corresponding change in x. So we have our 2 points. We just plug these numbers in. I chose to start with 7. I did 7 minus -5 in the top. I did -3 minus 2 in the bottom. And, without a calculator, I figured out that that's -12/5. Step 1. Now, step 2 is where you and I probably differ. My goal for step 2 is I want to be smart. And by smart, I mean efficient. I want to cut down the amount of time I need. And if I'm going to be efficient with a line, I'm going to use point-slope form. Point-slope form generically. You take the generic y, you subtract a very specific y. You set that equal to the slope times the quantity of your generic x minus the corresponding specific x. So, if I just simply take this generic part and I fill in my slope from above, and I just pick one of these 2 x's, it doesn't matter which one, maybe I choose the 2, and I fill in the corresponding y. Now when x is 2, y has to be -5, so I put that in here and I deal with a sign. I'm done. That's it. I have written the equation of that line. I'm all done. I do not get why kids fight this so much. It's so spectacular. It's so beautiful. Look at it. Woo, it's so good. You're done with the equation. You don't have to fool around and manipulate it that much. It's it. Well, all right, I kind of lied. Sometimes I make you manipulate it. Sometimes I ask you to rewrite it in standard form. And this certainly isn't in standard form. So let's just do a quick talk about standard form. The rules for standard form, there are just 2. No fractions. And the second rule is it has to be x's first, y's second on the left, the constant on the right. Hence the standard of standard form. So let's say I did ask you to put this equation in standard form. We have a little bit of manipulation, but nothing you can't handle. So let's take a look. There's the equation right there. I would say the first thing I'm probably going to do, let me switch out of this pen, is I'll probably go ahead and take this and distribute it through the parentheses. So what's that give me? That gives me y plus 5, nothing changed on the left. And then distributing, I'm pretty good with fractions. Although, remember, standard form, we don't want fractions. So to get rid of the fractions here, I'm going to use that old Algebra 1 trick of multiplying both sides by the common denominator, which appears to be 5. So I'll distribute that 5 all the way through, and what's that give me? It gives me 5y plus 25 on the left. Of course, the 5's cancel out. And then I need to standardize this. So I need these x's to go over here, and they need to come first. The 5y can stay. I need that 25 to move over here. So when all is said and done, boom, there's my equation in standard form. By the way, it never hurts to check your answer. If you recall, one of the original points we had was the point 2, -5. Well, if I go down to this equation and I put that 2 in for x and the -5 in for y, it's a true statement. I could do the same for this -3, 7. If I put -3 in for x, 7 in for y, again, I get a true statement. Now, I did ask you to do some homework problems for me tonight. I hope you watch this video so your homework problems go quickly. Some of them are very direct, just like what we talked about. Others, you need to think about. And, luckily you're honors kids. You're pretty smart. Just to give you a picture, problems 1 through 4 right here, I put these color-coded in there so maybe it kind of helps you figure out those points. Of course, problems 1, 2, and 3, I'd probably use slope-intercept for those. I mean, you can find the slope just by counting, and you already know the y-intercept. That'd be a kind of easy one to do slope-intercept. But number 3, I don't know. That one I might do some point-slope form for before I change it into standard. So I'm going to go ahead and put the answers up here. You might want to freeze it on this page. Try the problems and do the work. But the answers are coming up in 3 seconds. Hey, welcome back. I do hope you paused it and tried it for yourself. Don't be that lazy kid who's just copying down the answers. And, oh, well, look at that. The answers didn't show, so take that. I guess I'll just give them to you tomorrow. In the meantime, let's try the next page. Again, this time I did ask you to do standard form. You probably can't go, you definitely can't go directly into standard form. But play around with this. Again, I'm going to put the answers up to this in about 3 seconds, so pause it, try the problems on your own, then check your answers. I do expect to see work for this. You're not doing this in your head, so do the work. Hey, welcome back. I hope you did the work. Here's the answer to number 1. Again, this is in standard form. I had to do quite a bit of work to get here. Make sure you show your work. Here's the answer for 2. Number 3, actually, I should be honest, I didn't do any work for number 3. I could tell that this was a vertical line and x was always going to be -3. Sometimes it helps to think through the problem. Here are the answers for the rest of them. Problem number 4, again, the key word is parallel. Problem number 5, key word is perpendicular. And problem number 6, oh, I only get maybe 3 to 4 kids in every class every year who get this one. There is your answer. So if you missed any, go back and see if you can find your mistakes. We'll talk about this tomorrow.